So coming back to this problem, we are going to determine the factor of safety. We drawn this structure over here, okay, and then what we are, the fact that they say that during load or during loading, the load will always be in line or parallel to the centroid. So we are going to assume pin at both ends. Okay. So when we assume pin at both ends, then we can apply P critical pi squared EI over L squared. If not, later on I will show you, if it's not pin in both ends, how this expression will evolve. Okay, and it's not difficult at all. Okay, the only thing will change, which will be, if I can teach you today, I will, is the length. Okay, right. So coming back to this problem, as I say, this is it's a real world 3D problem. Okay, so we are going to see, okay, what are the possibilities. Okay, we are going to find out the how is this structure going to buckle. Okay, this is important. Okay, so the first thing that I would like to do, if we are going to look at buckling about two planes. Okay, so some of you say, what do you mean by buckling? So we are going to look at buckling. Okay, buckling in the X, Z plane. Okay, some of you might say, Eugene, what is the XZ plane? So now, if I were to draw our structure in the XZ plane, okay, so this is your XZ plane. Right? That's your XZ plane. So if we look at the structure of the XZ plane, it will look like this. Okay. And then you have this center feature, dotted line. And then you have this green line over here. Okay. Right. Okay. So the load P will be here. So if I'm going to draw so for this case, this will be our rotation about Y using right-hand rule, right? So the structure, let me draw the rotation pattern first. Okay, so this is the rotation, right? So the structure will buckle on the exact plane. So this is how the structure will occur, right? The centroid, that's how the buckling will look like. And if we are to apply the formula, you will apply that this is P critical will be equal to pi squared E over L squared. The I will be about the y-axis. Okay, I repeat again, the Y will be about the what? Will be about the y axis. Now, why is that? Okay. Because if you were to look at the curvature, which I'm highlighting in green now, right? In yellow, the curvature and the rotation about the y-axis, the curvature is in the same what? Orientation. So if it's the same orientation, the buckling is buckling about the y-axis, right? It's buckling about the y. Yeah, it's buckling about the y-axis. That's why we use what? IYY. Okay, so that is buckling in the exact plane. Another possibility is that the structure will buckle buckling in the exact plane. Sorry, XY plane. And now if we were to look at the structure XY plane, this is our XY plane. Okay, there is the XY plane. So if I'm going to sketch the XY plane, the structure of the XY plane, it just look like this, right? Oh, hold on. The structure will look like this. And then I'm going to sketch the centroid, the geometric centroid. All right. And this is our P. Right. Now we realize that P is in the X orientation. Okay, regard. So if I were to draw our transformation over here, what are we looking at? Okay, so now we are looking at this is our Y, this is our X, and then we have rotation in the Z direction. So if we see how the structure will buckle now, right? Now the buckling orientation is this way. Now it can be in the it can be the other orientate on the other. Wait, let me tell you what is the other. So it can buckle in. It will buckle in this direction. Okay. So what? Let me finish here first. Okay. When it buckle in this direction, if you look at the curvature, and this curvature is in the same orientation, so we know that PCR is equal to pi squared E over L squared, okay, IZZ. Okay, that is our IZZ. So now when you look at this, okay, so why IZZ? Because the curvature. Now the deformation or the deflection also can occur in this orientation. It's possible. I'm not saying it's not possible. Okay, why I use this orientation, I want you to relate to the curvature of the RZ over here. That's all. Okay. Now, a lot of times, I know a lot of times, I've been teaching this course. This is my what, 10th time or 11th time. So I know for the fact what is the difference between IYY and what IZZ. Okay. So if you look at this equation, or if you look at PCR, okay, in the XZ plane and the critical load in the XY plane. Okay, so if we were to look at this equation over here and this equation over here, right? Both of them have the same Young's modulus. Both of them have the same what? Have the same length. The only difference is the what? Second moment of area. Okay. So now let's look at the second moment of area. Okay, so I'm going to take this image over here. Okay, and I'm going to string this down. Okay. I don't want to make it too small. I want you to see the difference. Right. So one left and one right. Both of them share the same orientation. This is our Y. This is our Z. Okay. So again, so for this case, we are going to focus on IYY. Okay. So if you look at the axis, okay, if you were to look at the axis over here, this is your Y. I'm going to draw a orange line down. Okay. So this is our YY axis. On the one on the right hand side, it wants to use the second moment of area about I Z Z. So Z axis is this orientation over here. That's our Z. Then we are going to draw a horizontal line. This is our ZZ. Okay, there is our ZZ. So when you do this, so how will this help? Okay. Now the in general, the formula I. So the general formula for I. So I is equal to width times depth cubed over 12 plus by width times depth multiplied by y bar minus small y bar squared. So this is the general formula. Okay, this is the general formula. Okay. Now y bar or y bar, the only thing, so W is the width, D is the depth, y bar, capital Y bar. Okay, there's a difference here. One big Y bar, one small. Capital Y bar is the global centroid position. Small Y bar is the individual centroid position. Okay. Now, so for this case, when it's YY, so I've done a lot of problems with this, okay, and as I say, I've taught this so many times, okay. Students usually have problem is what is the width and what is the depth, okay. So I came up with a very easy method that you can't go wrong, Okay, I highlight again. You can't go wrong. Okay, so what do I mean? The axis that we're interested is YY. So the axis that is parallel to the axis of interest